Let's welcome to Diego Rossi from the Federal University of Juiz de Fora in Minas Gerais, Brazil, who will present a joint work about the design of an architecture that combines actually two powerful techniques, conversational agents and recommendation systems, in order to detect students' needs and somehow intervene with recommending learning resources. So the paper is entitled CAES, which is the name of the architecture, which is a conversational agent for intervention in MOOCs learning processes. So Diego, when you are ready, you can start, please.
Okay, I will present to you the work that deals with the CAIRS, a conversational agent for intervention in MOOCs learning process. The authors are below. I am Diego Rossi. The MOOCs environments expanded and democratized education where several renowned universities started to offer courses in this modality. While the expansion of MOOCs is noticeable, the number of dropouts is also very high. However, due to large number of students for a low number of tutors in this teaching modality, it is a challenge to able carry out pedagogical intervention on time, but the use of technology makes it possible to fulfill this task. This work proposes an architecture called CAIRS, Conversational Agent in an Educational Recommender System. When a post in a discussion indicates that there is a need to carry out a pedagogical intervention, the subject of the message is recognized. Then education content is recommended for the student in an attempt to clarify doubts about it. On the slide, we have the image of the architecture where I will better explain each of your components. The first component is data, responsible for obtaining information from external sources to supply the system. Then we have the extraction component, which has the function of grouping the information about the previous component and providing information, the filter and the knowledge component. The knowledge component can understand the context, provide information for both the conversational agent and the recommendation algorithms. The recommendation component's function is to select open educational resources which are more relevant according to parameters passed by other components. The conversational agent aims to interact with the student and obtain information according to message posted on the forum. The application component is the user interaction interface. The experiments were conducted using data from messages posted by students in the MOOC discussion forum. The data collection used is Stanford MOOC posts, which contains 29,604 messages captured from forums of 3 courses in different areas of knowledge. For 14 months, these messages were labeled by hand with the following attributes: text, opinion, question, answer, sentiment, confusion, urgency, course type, forum post ID, course display name, forum user ID, created at, post type, anonymous to peers, up count, comment thread ID, and readings. For the work only, the attributes urgency, sentiment, and confusion were used as they added more knowledge to reach the objective of the work. These attributes were also used in other works. Based on the confusion attribute, it was possible to train a predictive model of supervised machine learning algorithm. According to tests performed, logistic regression obtained better performance. Data were partitioned in 80-20 ratio, where 80% is used for training and 20% to evaluate the model. The model was trained using k-fold validation with k equals 10, a cross-validation technique to avoid the model overfitting. For the model not become biased, it was necessary to balance the classes. The technique used to equalize was the oversampling, where new examples are generated so that the model is not biased. Total accuracy of 84.3% was obtained. Therefore, the result was quite satisfactory, as most of the cases, the model was able to detect the need for intervention. If need for intervention detected, the conversational agent will send message directly to a student. In this figure represented on the slide, it is possible to understand the stages of agent's operation. The first step is to extract the keywords from Stanford multi-posts dataset through natural language processing techniques. From these keywords, we check which words are related or evoking. Tools that meet the condition are loaded into an ontology, and the words from ontology are transferred to Dialogflow so that it can recognize the context of the post. On the slide, we have the ontology represents the classes in their relationships among the most important classes, term, field, and domain. These are most important considering that they will be reused by the conversational agent. To create a conversational agent, we use the Dialogflow tool as it is helping in creation and integration of conversational interfaces. There is the possible of integrating Dialogflow with services as it works in APIs. In this work, the prototype was developed following the steps present on slide 10 and using Dialogflow as initial user interface. In this figure, we have the diagram representing the agent operation, where the student message is received as an input, the keywords are recognized, and then a confirmation is requested from the student for the context that was identified in the post. If confirmation is positive, educational resources are recommended. Otherwise, the student asks for more details the subject of the post. The recognition keywords is performed again if the student confirmation regards the context is positive, content is recommended for him. Otherwise, tutor assistance is requested. In this slide, we have the conversational agent interacting with a student for a message. The agent recognizes the context and asks the student if he is in doubt about that particular subject. As this answer was yes, the agent recommends a video content. Final considerations and feature work. The novelty is this work is union of two powerful techniques to assist in pedagogical intervention, that is recommendation system and the conversational agents. The recommendation systems has not been widely exploited. Resources have been limited to videos from the YouTube platform only. As future work, we plan to expand the prototype and improve it, making the recommendation system more powerful. On the slides, we have the reference. Thank you. I will leave a space for questions.
Okay, thank you, Sergio. Thank you very much for your nice presentation. So now have time, actually plenty of time for questions. So, well, in the meantime, that we wait for some questions in the Q&A box. I would like to ask some questions. Well, as you know, this is a joint work that I am also involved, but I think that especially for the audience, could be interesting to clarify how the model, the system itself, works to identify the right moment to intervene with recommendations to the students, and how these recommended resources are identified. That is one of the key points of this research that is important to make clear. So could you please elaborate more on that, especially how the recommended resources are identified? Are they come from direct requests from the students, explicit requests from the students, or they can be inferred from the behavior of the students in the system or during the instruction?
Okay. Through logistic regression models, it is detected when a student need for pedagogical intervention.
Yes. So how the system knows that what a specific resource, let's say a video, book, whatever, the student needs at a specific moment, how the system knows that? It's because the student requests that, or is also is a combination with what the student explicitly requests, and also the system is able to infer what is the pedagogical problem the student has. I don't know if I was understood. And we have another question from the audience, which is much more interesting, I think, and it's worth considering now. Can you, Diego, read the chat, the question and answer box with the question? Can you read it from on your side? I can read it. Huh? So the question is, why did you select a logistic regression for text classification? The most recent works on text classification use neural networks. Are you going to test them in the future? Or have you already tried neural networks and they perform worse? So question is about comparing logistic regression and neural networks. Whether you have tried both and compare, and why do you select logistic regression? Could you please elaborate on that?
The studies indicated the logistic regression was promising.
Okay, I see. I see. So it comes from the feedback from the users that you believe that the logistic regression outperforms the neural networks. Okay. Okay, good. So there is no further questions from the chat. I think we can close now this talk, this very interesting talk. So thank you, Sergio, again. Okay. And now this also closes this first session of the track Alice. Thank you again for joining and for your participation and involvement. I think it's been a very interesting session about well, conversational agents, dialogue-based systems to support the learning and teaching processes. I think we all learn a lot from that. And above all, we learn also that there is a long path ahead here and very interesting present and future about these systems, how they can effectively support education. So thank you again. And actually, this is stop. We post actually this Alice track Alice, and we resume the track Alice after the break, where my colleague Nicola Capuano will chair the second session. So hopefully we can meet all of you again and other people interested in the track. So thank you again, and we close here.